let's just talk about the another concept which is all about the geometrical meaning of the zeros of the polynomial. As we do know about what is the meaning of the zero of the polynomial, any term k is called as the zero of the polynomial p of x. When we will substitute x is equal to k, the polynomial gives the value as nothing but is equal to 0, then that particular point is nothing but called as the zero of the polynomial. So what is the geometrical meaning of the zeros of the polynomial? So let us suppose we are considering any particular linear polynomial as ax plus b, where a is non-zero, and for an instance we are taking an example as y is equal to 2x plus 3. Now for this linear polynomial we will plot this linear polynomial. So in order to plot this linear polynomial, or in order to know about the geometrical meaning of the zero of this linear polynomial, we have to plot it. So let us suppose I am taking the different values of the x and I will get the different values of y at the last. So let us suppose I am constructing this table as let us suppose I am taking x as minus 2. It means we have to substitute x is equal to minus of 2 in this linear polynomial. So 2 into minus of 2 is minus of 4 plus of 3 results in minus of 1. It means for the value of x is equal to minus of 2, the value of y is nothing but minus of 1. Further, let us suppose I am substituting x as nothing but 2 in this polynomial. So if I'll substitute x as 2 in this polynomial, so 2 into 2 is 4, 4 plus 3 is nothing but 7. So at the end the value of y is coming out to be 7. So I am only writing the 2 values over here, but definitely I am taking more than 3 values, because in order to plot any particular polynomial we do have to take more than 3 values. So let us suppose I am writing only 2, but I am plotting more than 3 values for this particular polynomial. And the other thing and the important thing is, always remember, whenever we do have a linear polynomial, then whenever we will plot such kind of a linear polynomial, it always results into a straight line. It always results into a straight line. So y is equal to 2x plus 3 would definitely be a straight line. So let's just draw the graph. So first of all we have the Cartesian plane in this way. So let us suppose I am taking 4 points, as I have written only 2 points, but I am taking the 4 points. The very first point is 2, 7, the second one is 0, 3 coordinate, the third one is minus 3 by 2, 0, and the fourth one is minus 2, minus 1. So these are my 4 coordinates: 2, 7, 0, 3, minus 3 by 2, 0, and minus 2, minus 1. So let's just join all these points. So when I'll join all these points, I will get a straight line which is nothing but of the form y is equal to 2x plus of 3. So this is nothing but the graph of the linear polynomial y is equal to 2x plus 3. So what we have concluded from this particular graph? So let's just talk about the conclusion. What we have concluded from this particular graph is nothing but that the linear polynomial ax plus b, or let us suppose I am talking about 2x plus 3, because I have taken an example of 2x plus 3. The linear polynomial definitely has exactly 1 0, which is nothing but called as the x coordinate of the point where the graph intersects the x-axis, where the graph actually, or the graph of y is equal to 2x plus 3 is intersecting the x-axis at that particular point. Or we can say the x coordinate of that particular point is nothing but called as the zero of the polynomial. So using this plotting system or plotting the graph, we can also find out the zero of a polynomial. So this is all about the geometrical meaning of the zeros of the polynomial. Whenever we wanted to find out the zero of the polynomial, then we can able to plot them, and wherever they intersect the x-axis, the x coordinate of that particular point is definitely called as the zero of the polynomial. So if we are talking about y is equal to 2x plus 3 and we are looking for the zero of this particular polynomial, then we can see the straight line is actually intersecting the x-axis at the point minus 3 by 2, 0. Minus 3 by 2, 0. So minus 3 by 2 is nothing but the x coordinate, and thus it is called as the zero of the polynomial, and hence it has exactly 1 0. So 2 points are coming out from this geometrical meaning. First of all, we can able to find out the 0, and the second thing is it do have exactly 1 0 because the straight line actually intersecting the x-axis at only one point, at only one point. So it is intersecting the x-axis at only one point, which means it has only 1 0, and the x coordinate of that particular point is called as the 0 of the polynomial. So for y is equal to 2x plus 3, x is equal to minus 3 by 2 is the 0 of the polynomial, and it has exactly 1 0, that is minus of 3 by 2. So this is all about the geometrical meaning of the zeros of the polynomial in case of linear. Let's just further talk about the geometrical meaning in case of a quadratic polynomial. In case of a quadratic polynomial, so let us suppose we are considering a quadratic polynomial as x square minus of 3x minus of 4. So let us suppose we are writing it as y is equal to x square minus of 3x minus of 4. Again, let's just plot this quadratic polynomial, and let us suppose we are taking the different values of the x, then we will get the different values of the y. So let us suppose I am taking all these values of the x, and I do have all these values of y. So I am taking x as minus of 2, and I will get y as nothing but is equal to 6. So it means, let us suppose I am considering this particular polynomial as y is equal to x square minus of 3x minus of 4. So for the different values of the x as minus 2, as minus 1, as 0, 1, 2, 3, 4, 5, we have different values of the y as 6, 0, minus 4, minus 6, minus 6, minus 4, 0 and 6, and so goes on. So for these different values, I am taking all these coordinates and plotting the graph of x square minus of 3x minus of 4. So let's just talk about the graph. The graph should be of the form, so let us suppose plot the points first. These are the points, that is minus 2, 6, minus 1, 0 and so goes on. Let's just join all these points all together. So when we will join these points all together, we will get a particular curve of this formation. This is the graph of y is equal to x square minus 3x minus 4. So here is a very special note. Always remember, or let us suppose I'll write a note over here. Always remember the graph of the quadratic polynomial. The graph of the quadratic polynomial. The graph of the quadratic polynomial ax square plus bx plus c is called as, or the curve we can say of the quadratic polynomial is called as the parabola, is called as a parabola. The graph, or we can say the curve, what we are talking about, the graph or the curve that is formed over here is nothing but called as a parabola, and this parabola is all depend upon the value of the a. Whenever the value of a is nothing but greater than 0, it is in the upward direction, and whenever a is less than 0, it is always formed in the downward direction. So the graph or the curve of the quadratic polynomial is called as a parabola, and the parabolas are formed depending upon the value of a, that is, if a is greater than 0, then parabola is of the form this, which is in the upward form, and if a is less than 0, the parabola should be in the downward form. So the parabola is in the downward form, downward form or it should be in this particular form. So as we can see in this particular quadratic polynomial, if I'll represent it as ax square plus of bx plus of c, then we can see that the value of a is nothing but 1 and a is 1 means a is greater than 0. So the graph or the curve, we can say the graph, or we can write it as a curve as well, or the graph or the curve of a quadratic polynomial should be in the upward direction. So it is formed in such a way. So what we have concluded from this particular graph is